All right. Hello, everybody. This is Miss Pikarski. I hope you had a great Christmas vacation. If you are watching this video, this means I had an awesome vacation and I'm not back yet. Hopefully, I will be here tomorrow. However, I am going to be helping out with Challenge Day, so if you aren't part of Challenge Day, then you won't see me until Thursday. We'll have a sub for the next 3 days, and I'm going to do these videos, so please pay attention and take notes and follow along. Put your phones away and make sure you're following along. And be very nice to the substitutes. They need you to be nice to them so they don't run away screaming and never come back. All right, so let's go ahead and get started with this new unit. As you can see here, I've got a little treasure map, and we have this pirate right here, and he needs to get to the treasure. Well, on his map, the map tells him that he needs to go up, or he needs to go north for 4 miles and then east for 3 miles. And he can go that way, but everybody knows that the closest distance between any 2 points is a straight line. So another method he could do, or another way he could go, is he could go this path here. And if you recall right triangles, you can do the Pythagorean theorem to figure out the distance from here to here. Hopefully this is all a review. And so if he goes on the hypotenuse, or the straight line, then he only has to travel 5 miles instead of 7 miles. Okay? So this basic concept, I know it's really boring, you've seen it and done it before, but we're going to apply that Pythagorean theorem, the hypotenuse, to lots of different scenarios in this unit. And what we're going to be looking at or focusing on is called vectors. And let's say you need to know how to get somewhere. So how do you get to the bus stop? And with vectors, you have a direction and a distance. Okay, so we're combining those two things. So when this guy replies, go north for 2 blocks, well, the north is the direction, and then the 2 blocks is how far to go, or the distance. All right, so a couple things you need to know. These are in your notes, so make sure you fill out all the underlined parts. There's 3 different things you need to know about vectors. You need to know about the components. So you're going to count the number of spaces from the dot, or the starting point, to the arrow like coordinates. So if you're going left, then it's a negative. If you're going right, it's a positive. If you're going up, it's positive. If you're going down, it's negative. So very similar to your coordinate, or your grid. If you have a y and an x axis, let's see, there's x, this is y. This is positive. If you're going up, it's positive. If you're going to the right, it's positive. If you're going down, it's negative. If you're going to the left, it's negative. Okay, very similar to our XY coordinate grid. Okay, so those are called components. We'll get more into that in a little bit. Now your magnitude is the same thing as distance. The reason why we say magnitude instead of distance is sometimes you could this could be a force too. And then later on, when we start applying vectors to real life situations, it could be force or speed or distance. There's a lot of different types of magnitude that you can have. But initially, when we first start out, it's mainly going to be distance. Okay, and that tells the magnitude, or the distance tells the distance or the length in coordinate units from the dot to the arrow. The distance may have to be determined using the Pythagorean theorem or the distance formula. Okay, so I know we're all very familiar with the Pythagorean formula. We'll do a refresher on the distance formula in just a minute. All right, so with vectors, you have distance and direction. The direction tells the rotation angle associated with the picture, where the dot is the center of rotation. 0 is the positive horizontal direction, and 180 is the negative horizontal direction. Okay, so I know we are used to having an x and y axis, and our origin would normally be the starting point with our rotation angle like this. Well, there's sometimes, if you have a grid okay, like this, you have several different lines, right? Well, if you start here and you rotate this way, then this would be your rotation angle. Okay, if you start here and you're going this way, then your rotation angle would be from here to here. So it doesn't matter where your point starts, wherever that dot is, that's your starting point. Okay, and then the arrow, I know in previous units, when we worked with the XY axis, the arrow means that it keeps on going. With vectors, your arrow point just tells you what direction and when the end point is. Okay, so don't get those confused with thinking it's going to keep on going forever. Okay, now let's look at this worksheet that you picked up this morning or when you came into class. And notice that I have grids. I don't just have one X and one Y axis. And again, wherever the point is, that's your starting point, and the arrow's telling you which direction to go and where the end point is. Okay? Most of these are pretty easy to do. Let's do B together. If I'm going to do components, I'm going to start here, and I want to count how far left or right I'm going and how far up or down I'm going. Well, left and right, I'm not going anywhere, so it's just going to be a 0 for the left and right direction, and then for the up and down, I'm going to count 1 grid line, 2, 3, 4, 5, 6 grid lines. So the components are going to be a 0 and a 6. Now notice the 6 is positive because I'm going up. Now the magnitude, I don't have a well, my rotation angle would be 90 degrees, so the direction would be 90 degrees. But I don't necessarily have a triangle where you have the x-axis here and the y-axis here. So my magnitude is just going to be the length of this line, so it's just going to be 6 units. Okay? Hopefully you can do the rest of these. These ones, your direction would probably be 180 degrees. You guys can figure out the components and the direction. This one I'm going to let you work on, but before you work on that one, let's look at another example. Let's look at this example. So if we start here, my components for my X component, I would go over 1, 2, 3 units to the right, so that's going to be a positive 3, and then 1, 2, 3 units down, so a negative 3. So my components would be 3 and negative 3. Notice I'm using these kind of, my gosh, I don't even know what these are called. Instead of using parentheses, I'm using these to signify that it's a vector. Okay, open arrows, I don't know what they're called. I'll have to look it up sometime. All right, so now to calculate the magnitude or the distance, I'm going to use my Pythagorean theorem. Well, I have 3 here and 3 here, so 3 squared plus 3 squared equals c squared. So 3 squared is 9 plus 9 gives me the square root of 18. Okay, and I can simplify the square root of 18. Let's see, how did I get the 3 times the square root of 2? Well, if you divide 18 by 3, you get 6. Divide 6 by 3, you get 2. So if I'm going to simplify the square root of 18, I'm going to have a 3, and a 2. So I can pull out one of the 3's, and I'm left with the square root of 2 still stuck inside under the square root symbol. All right, now, yes, I know that you can plug that into the calculator and get 4.24, but I want you to leave it in the exact value, so 3 times the square root of 2. Do not leave it as the square root of 18 because you can pull out a 3 there. All right, and then what direction are we going? Well, my direction for my rotation angle, it starts here and goes all the way around. And because I'm going up to the right 3 and down 3, I know that from here, whoops, I'm trying to draw a straight line. From here to here is 45 degrees. So this is 270. So this would be what? 270 plus 45, 315 degrees. Or I can go have a negative angle and go from here to here, and this would be negative 45 degrees. So I can either have positive 315 or negative 45 degrees. Let's look and see what I have. Positive 315 degrees or negative 45. It is up to you on whether you want to have a negative or positive angle. Just make sure you know to start here and go around. This was from our last unit. All right, let's go. Let's look again at some of our information about vectors. So we've already discussed how vectors tell direction and distance. Let me erase that. All right, so vectors are defined as directed distances. This means that as well as having a specific length, they are also described by their direction. So that's the key difference between normal lines and angles and vectors. Okay, we're kind of combining everything. Vectors can be represented on a coordinate plane as arrows drawn from a initial point called the tail to the terminal point called the head or the tip. Okay, guys, these are all very similar to things that we saw last year in the first unit. I know this is a lot of information I'm throwing at you right now, but it's really not that difficult. There's not very many formulas you need to recall and memorize. So just make sure you understand the concept that this arrow does not mean it's going to keep on going. Your vector stops here. This is the end or the terminal point, and this is the initial point here. All right, so symbolically, vectors can be represented as bold lowercase letters such as V, or much like a ray. For example, the ray RP. So from here to here, this is vector RP. However, the arrow as a vector does not mean it continues forever. It simply indicates the, what's going on with my eraser? It's won't erase. Let me see what's going on. Oh, well, it will not erase. Oh, my goodness. So let me tell you what this says. It indicates the direction of the vector, which terminates at the indicated path. So that's something we've already covered several times. So right here, you should write the word direction. All right, and then let's look at your table of formulas. I know this looks like a huge mess. Let's break it down step by step. Okay. Excuse me. So you have three different terms you need to know: components, magnitude, and direction. For components, remember we're using these kind of open and closed arrows for our in place of our parentheses to indicate it's a vector, not a coordinate point. This would be your x value and your y value. So your horizontal direction and your vertical direction here. The ordered pair used to represent a vector. If vector v has initial point x1 and y1 and terminal point of x2 and y2, then you can find the coordinates like this. Okay? So so that's the components for your vector. That tells you from your starting point how far you're going to go left or right and how far you're going to go up or down. Okay, now the magnitude, you symbolize it with the absolute value signs with the V or for a vector in between. That's just how the length of your vector, so the length of the line. A lot of times you're going to use the Pythagorean theorem. Let me see. Yeah. A lot of times you'll use the Pythagorean theorem. I'll show you the distance formula in a little bit. I can't remember if I show it to you in this video or not. I'll look into it. If we get there, we get there. All right, so now the direction is the symbol we just used, theta again. Now remember last unit, anytime we use theta, we were always using radians. Vectors are kind of a lower level math than pre-cal and calculus. So sometimes we'll use angles, sometimes we'll use degrees, sometimes we'll use radians. Okay, so this is just our direction or our angle in either radians or degrees. Most of the time I think we're going to be in degrees. Every once in a while we'll get radians. Just keep your trig table out and don't forget how to change the between radians, degrees in your calculator. Okay, so now the definition is the direction a vector is pointing measured as a rotation angle from the positive horizontal axis. Okay, now our components, before we get into this part here, we need to look at our components. We're using our A and our B, so our X and our Y, and if we have our components and we want to know the direction, then we are going to use the inverse tangent formula. Remember, the ratio for tangent is y over x. Okay, y is going to be our b value, x is our a value. And if I know my ratio, then I can find my angle by doing the inverse of that tangent. Okay, but sometimes we will have if they're both positive, if we're here, then we can just do inverse y over b, a, and we'll get the right information. But what if we have what are we looking at? What if we have a negative x value? If it's over here, then a, or our x, is a negative, then we need to add, once we do the calculation inverse tangent of y over a, we're going to add 180 degrees. If we're here or here, we might have to add something else. But if our x or if our a is 0, let's say we're going straight down, okay, or straight up, then our direction, in this case, it would be 90 degrees. In this case, it would either be negative 90 degrees or 270 degrees. Okay? If we're on the positive x-axis, if I'm trying to draw a straight line, if we're going straight to the left, it's 0 degrees. If we're going straight to the right, it's 180 degrees, okay? So there's sometimes that we are not going to have to use this inverse tangent, and there's sometimes we will, okay? The biggest thing is to look at your x and y values, or your a and your b value, and see what coordinate, I can't think, it's too early, what quadrant you're in. That's the word I was looking for. Okay, focus on what quadrant you're in. That will help you figure out when you have to add 180, or if you're just adding or subtracting 90 degrees to it. All right, so let's go ahead and look at some examples. On this worksheet, let's see how far I'm going to go. Yeah, okay, you know what? We're going to go a little bit farther, and then I'm going to have the pause the video and rewind and give you guys the rest of the class time to work on some of these problems. All right, so let's look at this. We have a couple of problems. I want to look at S and let's see, S and V here. So for S, I'm going straight down, and my components are going to be 0 and -5 because I'm going 5 units down. My magnitude is just 5, and then the direction is -90 degrees. I could also put this as 270 degrees. And then for V here, I'm going over 2 units to the left and down 5 units. I'm going to find that my magnitude is the square root of 29. So 2 squared is 4, 5 squared is 25. So 4 plus 25 gives me 29. So the square root of 29. When I plug that in, I get 5.39. Again, give me the exact value. If you can reduce it, reduce it. Now the direction, when I put it in my calculator, I'm going to do inverse tangent of -5 over -2, and I'm going to get 68.1986 degrees. Now my calculator's in degree mode. Well, 68 is in the first quadrant, not the third quadrant, okay? So I need to add 180 to that, and I get 248.19 degrees. So now I'm at 180 and then 248 degrees. All right, let's move on. So, hold on. So I hope you guys saw how we did that. Let's look in our notes again. A vector is said to be in standard position if the initial point is at the origin. When located in standard position, the components of the vector match up with the coordinates of the vector's terminal point. Define each of the following in terms of x and y and magnitude. So let's think back to our unit circle. If this was my unit circle, this would be my x and my y, and my cosine ratio would be x over my radius, or my, in this case I'm using the vector component or magnitude. So for cosine theta, it would be x over the vector magnitude, and for sine it would be y over vector magnitude. Okay, but what if I wanted to get x and y by itself? So in this case, I want to solve for x. Well, all I have to do is multiply both sides by the magnitude. And so if I wanted to solve for x, it would be my magnitude times cosine of my angle. If I wanted to solve for y, or get y by itself, I would multiply both sides by the magnitude, and I'd have magnitude times sine theta. Okay? So the reason why I'm showing you this is because there's some times where we have the magnitude and we have the direction, but we do not have x and nor y values. Okay, if that's the case, we can use our formulas. Excuse me, I'm switching back and forth. We can use this formula to find x, and we can use this formula to find y. So let's look at these problems. We have magnitude is 12 and direction is 60 degrees, and I want to find my components. So I plug all that into my calculator. In this case, round to 3 decimal places. So my components for cosine 60 times 12, my magnitude is 6, and sine 60 times 12 is 10.3923. Okay? That's one example. It's very easy. Use your calculators. Okay, here's another one. Here's my angle and my magnitude. When I plug it into the calculator, I'll get this. This is my cosine of -54 times 5, and this is sine -54 times 5. Anytime you do that in your calculator, make sure you have the angles in parentheses and you do times the magnitude out here. A lot of times it helps if you type in the magnitude first up here and then do times sine of 60 degrees. Okay? Alright, so that's that one. And then this last part, I'm trying to remember if I went through any of these. I don't think I gave you the answers on any of these. Let me see. I know I did a picture. Oh, I did do the answers. All right. So you have a plane is heading northwest for 50 miles. Well, northwest is this direction. This angle is going to be 135 degrees. How do I know that? Well, halfway between north and west is 45 here, plus another 90 gives you 135 degrees. And it's going for 50 miles. So the vector, or the magnitude, is 50. So I plug that into my calculator and I get that information. On here, a ramp has 30-degree inclination. A kid on a skateboard rides down the ramp at 14 feet. With the inclination, you need to know that it's inclining, so that it's this distance here is 30 degrees, or here is also 30 degrees. So he's going in this direction. Notice it's negative 30 degrees here, and he's going down the ramp for 14 feet, so the magnitude is 14. I'm going to let you set up this. The next one, an airplane leaves a runway going 220 miles per hour, flying at an angle of elevation of 15 degrees. Now, this is miles per hour, but it is still a direction. So we can, this is why we use magnitude and not just direction, because this is how fast we're going as well. Well, our picture would look something like this. The magnitude is 220, and the angle of elevation from here is 15 degrees. All right, now you need to find the rest of the information. This is the end of my video. I want the sub to, he or she can go ahead and rewind this and show you guys different parts again if you want to. You have the rest of the class period to work on this worksheet. Please go ahead and get it turned in before the bell rings if you can. If not, it's homework. All right, and I know most of you don't have graphing calculators at home. All right, so I will see you guys hopefully on Thursday. I hope you had a great Christmas break, and I will talk to you Thursday.